Resource Center at Cornell. So he'll tell you a little bit about the resources they have there for Nanopore sequencing.
All right, let's see if my volume is okay. Is that too loud? We're okay. Okay, and I want to thank Susie for organizing this thing, because in a few minutes I'll talk about the challenges of running MinIONs or Oxford Nanopore in a core when it's pretty much freely available to anybody who wants one. But most of you know me from the core facility for a lot of the other technologies that we run, and so I'm just going to give you an overview of what we have. There are a couple of instruments that you may not realize that we have, and we do a lot of things, obviously, but and I apologize for the people who are live streaming, because I'm definitely not as interesting as Gus's talk, which is fabulous. Incredible things you're working on. And just before I get started, so we've been running a couple of MinIONs for maybe a year now or so, and it's a little bit difficult for us to know what's going on campus, because we have them, or they're part of our lab, but there are probably at least a dozen, maybe more on campus, and we don't even know what people are doing. So people have come to me and said, we want to do RNA sequencing. Can you do it? And I say, well, we've never done it, but probably somebody on campus has done it. So I appreciate you getting us together so we can share experiences. If you want to volunteer that you've been working on RNA sequencing, we'd love to talk to you. But we're all about instruments in the core facility, of course. We gather these instruments, and it's all a lot of practical knowledge that we have and the ability to run these things. We have lots of them, lots of different things that you can utilize for helping with your experiments. We've got all the standard DNA quantification instruments, things like that, and multiples of things. And as I said, we have access to 2 MinIONs in the core. They're actually sort of a joint program with Ed Buckler's lab at the USDA, but we do have 2 MinIONs set up. There's a picture of one of them. And we've been running them for, as I said, about a year now. And in the lower right, left-hand person is Xiaoyun. You can raise your hand there. She's the one who's been doing the bulk of the work on the MinION runs, but Jing is right next to her, who can help out with those also. She's been helping out. So if anybody want to talk about practical lab-based methods, you can talk to one of these two. And we do offer it as a service, so we have a price associated with that on the lower left for MinION for a single. Everything we've been doing is basically long reads, so genomic stuff. A single library would cost you $1,200. Library prep plus the run. We can do barcoding. We just did a 3-sample barcoded pool not long ago, or probably 2 weeks ago, maybe. And we've been getting really nice yields. Upper left is one of the runs we did, up to, we're getting up to 100 kilobase reads out at the far end of that curve. But one of the funny things about Oxford is we've sort of gone back to our roots in a lot of ways. Many of you, some of the older people like me, when you went to isolate high molecular weight DNA, you might spool it out on a glass rod or loop it out after precipitation. One of the things we want now is getting back to getting high molecular weight DNA, which has sort of gone out of vogue with all the Illumina sequencing we've been doing. And most of you, so here are a couple of instruments that we use in the lab. You know about the one on the left, I'm sure, if you've run anything through us. This is the AATI fragment analyzer, which is equivalent to the bioanalyzer. And I apologize, I should have changed the name of it. It's now been bought by Agilent, so it's now an Agilent fragment analyzer. They bought AATI not long ago. And that's for small molecular weight things, DNA and RNA, obviously, and many of you have run through that. But the same company makes a second instrument called a femtopulse. And this is really useful for looking at high molecular weight DNA. And it's basically the same box, but it runs in a pulsed field mode, and so it can look at very high molecular weight DNA. And whereas the bioanalyzer goes up to about 6 kb on the highest molecular weight, the femtopulse can go up to, well, the upper marker, the highest marker is 165 kilobases. And we can see things above that, we just can't accurately size them. And so on the upper panel is actually tomato DNA that was done here. Now I'm blanking on her name. High molecular weight DNA, Julia Vreblov, tomato DNA. And the other thing that the femto can do, which isn't really all that applicable to MinION sequencing or nanopore sequencing, is it's incredibly sensitive. It can go down to femtograms of DNA or RNA. Just to let you know that, if you have something that you can't see on the bioanalyzer, we could actually probably see it on the femto pulse. But this has been incredibly useful for looking at the size of your DNA before you're sequencing. So one of the things that we've run into is that we do want to get rid of the small molecular weight DNA going into the MinION. And Gus talked about it's a sort of it does represent the pieces of DNA that you put in, but certainly you want to get rid of that small stuff because on a molar basis, is that right, molar or gram basis, whichever, it vastly outnumbers the big molecules that you want. So we do try to get rid of that small molecular weight stuff, and we have two ways. So we have another instrument, which is the blue pippin from Sage Sciences. Many of you have used this to do size selections. We've used this many times for size selections. And we can set it to collect anything over 40 kb, 50 kb, and there's an example on the left of a starting DNA sample, and then after the size selection of the Sage blue pippin, we cut out all the low molecular weight stuff there, and then threw that on the MinION. The blue pippin is a bit of a finicky instrument, so it can fail, so you lose your sample. It can run odd, and so it's not a tremendously reliable, 100% reliable instrument. It also takes a lot of material to go into it, and so you can take a pretty big loss if you put it on that. Yeah.
And so I can't quite see the axis here. Are you also losing some of the longer?
We probably do lose the longer stuff too. Yeah, because it is simply an electrophoresis, and probably a lot of the big stuff, like you know how agarose gels work, a lot of the big stuff probably doesn't even go in. There's probably an exclusion at the highest material stuff. Yeah, I wouldn't be surprised if we lost the big stuff. In addition, the other kit that we've had good success with, and maybe Gus knows something about this, and I know very little about it, but Xiaoyun's back there and she can answer any questions you have, but Circulomics is a company that produces a short read eliminator kit, SRE, and this is a very simple protocol, and instead of, for the blue pippin, you have to do pipetting in, pipetting out after the run. The Circulomics SRE is basically a precipitation, a differential precipitation of the high molecular weight material stuff, and so it's much less pipetting, things like that. Is that right, Xiaoyun? Have I? That's right. Yeah, yeah. Yeah, so we've had good luck with this SRE kit from Circulomics for the sizing. And I think that's really all I wanted to talk about. But I'm happy to talk about any of the stuff that we do, how you would submit samples to us, you know, designing a project, things like that. But we have the expertise to run it. We would love to know what other people are doing on campus, because running this as a core service, which is what we want to do, is difficult when all you people have or can get your own MinIONs if you want them. If there's demand for a Promethion, you know, come talk to me. We can see about getting one in. Would depend on having enough samples to run through the core. So please ask questions. We're happy to start the discussion. Thank you, everybody.
Any questions for Peter?
I mean, is anybody running RNA? No. Nobody is running RNA on campus, or cDNA. Yeah.
We'll do cDNA.
Uh-huh.
I'm going to show that Saturday.
Ah, good. Yeah, love to see it. Yeah. We've done both the ligation kits and the transposon insertion, and probably the transposon is easier. Yeah. Anyway.
So like you said, a lot of the things you can do it yourself, but we don't have access to MinION, for example.
Right.
Cheaper data. So is there a plan, or how?
There is no plan, and that's one reason it was great that this is set up, because we only know what people talk to us about, and if we can organize some effort to bring one to campus, we can easily do it. I mean, it's basically free if you have enough flow cells you want to run.
So there's no capital investment in that, basically.
Well, the basic is if you want to buy it, but that's always for people who either A, have only capital funds, or B, someone who has to physically own the instrument. Otherwise, we recommend our consumable-based model. So the Prometheus starter pack is $165K, but it comes with 60 flow cells. The sequence is 61. So, I mean, I think this is one of the things that what we're trying to organize here is, you know, if you have a couple of samples, if all each have a couple of samples, the core can then justify getting a starter pack and running those 60 flow cells, and then moving forward from there, there's just an annual software license and device warranty. You buy flow cells as you need. Right? So I think, you know, what Peter's looking for here is the initial project to justify bringing in those 60 flow cells in the instrument.
Yeah, we would.
One thing we've done in other places is we don't use a user community like this. We can set up like a monthly call for FAS, and we can go into details of the weeds about specific projects, specific applications, what makes sense. You know, give the technical aspect and support that you guys would need. Everyone can do their one-off experiment. What we had found was people got them in MinION, got some preliminary data, put in for a grant, but ultimately they just want the data. Right? So when they get the grant and they have to do 100 and 200 samples, they turn to the core to do that. You know, to get to that point, you know, we're happy to set up those monthly calls or whatever would make sense to help with the most up-to-date data sets, the most up-to-date techniques, whether it be extraction, whether it be data analysis. Our FAS are knee-deep in that, the most up-to-date things.
And I'm pretty sure the way we did for the MinION flow cells, if we were to do that and get the 60 flow cells, we wouldn't get 60 flow cells today. We would be able to spread out the 60 over the first year or whatever.
So the start packs are 4 months. But that
Okay.
might be changes. So
Okay.
at a bare minimum, expect to get them over 4 months. They have a 3-month shelf life. So if you factor in the extra year of software license device warranty, you say you have a 7-month period minimum, and then probably use flow cells that past the expiration date and still work fine, and we have to warranty it.
Yeah. Yeah.
But yeah, I mean, it's just a matter of having the right project to get started in the future.
One other possibility, I contacted Sophie Zager at Fine Genomics, which is Cornell Tech startup in Columbia, and she was interested in forming some kind of collaboration. I talked to her a couple months ago between Cornell campus and Cornell Tech, and I know there's out there to do that. I haven't really followed up with her on that, but I was just trying to brainstorm ideas, but that might be some other way to bring. If she wants to bring part of Fine Genomics to this campus, there might be a way of increasing the interest.
Oh, that's interesting. This is the disconnect we have, I mean, with this 3 campuses, us, Weill Medical School, and the Tech campus. That's the first I've heard of anybody on that campus having any interest in genomics. Yeah.
She has a startup.
Yeah.
She did from Columbia, and then she got it in their Roosevelt Island with their own startup company.
Great. Yeah, so we might be able to leverage that somehow. Good. And I know there's been interest in the flongle. And we can run the flongle on
So yes,
the PromethION.
Full disclosure, the response to Flongle was a little more overwhelming than we expected. So there's a huge backlog of Flongle. That new facility that was built up in Nine is going to help relieve that when it's up and fully running. But we have a lot of Flongle orders we have to get through. So, yeah.
Yeah, so we've been running Flongle for really as a QC instrument. As we get running, our biggest sort of struggle has been getting DNA extraction. Everybody has getting DNA extraction. Our particular sample type working at a scale and a level that's like worth us getting it onto an ion or a PromethION. And we've been using the sort of reject Flongles from Nanopore. It's sort of 30 or 50 cores or something, and they've actually been really, I've been finding it very useful as a, rather than going on the bioanalyzer and getting one answer that may not correlate with actual sequencing performance. Storing it on one of these Flongles for an hour gives us as much information as I need to sort of say this was an improvement or not an improvement in my DNA extraction.
Yeah, because that'll give you a more real world, right? Let's say that like efficiency with library efficiency versus just the size of distribution, right? So if there's something, because we have seen, I'm assuming these are plant samples.
These are metagenomes.
Okay. We do see plant, we see a lot of brain samples too. They're obviously with metagenomics, there's going to be a bunch of stuff that could inhibit adapter ligation. So there are some stuff that get through QCs that still inhibit or slow down at least the ligation step and might need extended length of time, or maybe an additional cleanup, those kind of things. And then, obviously running on a plot will give you a clear answer very clearly.
This is more like a comment on compliance. We recently got a 16 flow cells on Nanopore, and all about that. And so it's a bad batch, whatever. But it took us, the salesperson or whatever, the support person that so forced us to jump through several hoops to get to get it replaced. So
why don't we talk about that offline? I'll get some more details for you to figure out a better way next time. But all 16 failed.
yeah, so that has 0 or 5 cores.
It sounded like there was a storage problem.
Storage or shipment, something happened during shipment, or...
Was this?
2 months ago.
Okay. I think I know what you're talking about.
But still, it's not like they know the whole batch is bad. So we still have to QC everything and then upload the image, and it took some time to get that reordered or whatever.
Well, first I'm saying I'm sorry, but thank you for the feedback. So, some of that has to do with us still being a relatively small company. So I think I know exactly what you're talking about.
Okay.
I think what happened was a shipment coming over from the UK or something got frozen. Okay, that's what happened. If whoever doesn't know here, if you do receive flow cells, do not put them in the freezer. They cannot be frozen. So, yeah, you shouldn't have had to test all of them, but yeah, let me get some more details from you after this.
Yeah, you'll do that once. Freeze your flow cells and then realize you've ruined it. Yeah.
The story on that. Follow the trend.
Yeah.
Other questions or comments for Peter or Gus? So I think what we're going to do now is just have a bit of open discussion. Maybe there are some people here that you'd like to talk a bit more about how they're using sequencing in their research. At noon, there is lunch, so if you're interested in coming to lunch, please come and see me. We have a lot of space available, so it would be great to have some more people engage with us at lunch. And other than that, we will meet back